is day 6. This is the replacement for the pages in the Regents review packet on exponential modeling. A rabbit population doubles every 4 weeks. There are currently 5 rabbits in the restricted area. If T represents the time in weeks and P of T is the population of rabbits with respect to time, about how many rabbits will there be in 98 days? So we don't have any sort of percent, but we have a doubling time. So we are going to use the formula, which you can find on your formula sheet for doubling time. So that's P times 2 to the T over D. So in this problem, we are given that we start with 5, so that's the P, 2 is the base, and here the doubling time is 4, so this is going to be over 4. Now for the time, actually no, let's write the formula at once. So that is my function, and then we'll figure out what to plug in for time. So we want to know how many rabbits there will be in 98 days. Now T is measured in weeks from my function. So I need to do 98 divided by 7 to find out how many weeks that is, which is 14. So we're going to find A of 14, which is 5 times 2 to the 98 over 14, or 98 over 4. Okay, because we're plugging, oops, sorry about that. Okay, take that back. We are plugging in 14 for T. So we have 14 over 4. So we're just plugging that 14 in to clarify. Then when I type that in, that's going to be about 56.57. Now that would round up to 57, but 56 is the closest option, and they probably decided to round down because it wasn't a full rabbit. The next one says Seth's parents gave him $5,000 to invest for his 16th birthday. He is considering 2 investment options. Option A will pay 4.5% interest compounded annually, and option B will pay 4.6% interest compounded quarterly. So first we want to write functions for option A and B that calculate the value of each account after n years. So I'm going to write A of n for account A. Now when we say compounded annually, that's basic interest. So that's P times 1 plus R to the T. Annually means once a year. So we're starting with 5,000. Our R value for option A is 4.5%, so I'm going to add on 0.045 to the 1 and then to the T. And actually that's A of n, so I have to be super careful. Even though we're used to using T, we want to use the variable n because that's what the problem says. So the next one, B of n. Now this one is compounded quarterly. Okay, so I'm going to put this formula over here. We're going to use the compounding formula, which is R over n to the nt. So we have P is 5,000, 1 plus 0.046. Quarterly means we're compounding 4 times a year, so there's a 4 there and then a 4t. The next one says Seth plans to use the money after he graduates for college in 6 years. Determine how much more money option B will earn than option A. So we're plugging in a 6, fixing the n over here first. So I'm going to do A of 6, which is 5,000 times 1 plus 0.045 to the 6th. And that will give me $6,511.30. For B of 6, we're basically just plugging in a 6 here. I don't really have room to write it, but if I typed that all in, I would get 6,898.27. So the question asked me, how much more will option B earn? So I'm going to subtract these two. So I'm going to do this number minus the 6,511.30, and the difference between those two would come out to $386.97. So this one doesn't say what to round to. Actually, no, it does, nearest cent, but you can assume nearest cent if you don't see rounding. Algebraically determine to the nearest tenth of a year how long it will take for the option B to double Seth's investment. So we know his starting investment is 5,000, so we want it to equal 10,000. The algebraically kind of gives me a hint that I'm going to be solving. So I'm going to write down, we're setting B of n equal to the 10,000. So the first thing we'll do is divide by 5,000. I'm also going to type in this decimal or this fraction or that number plus a fraction to get the decimal equivalent. That equals 1.01125 and then to the 4t. So I wrote this in different colors just to show this is our bend form. So this is our base, this is our exponent, and this is our number over here. We're going to put it in log Benny form, which means that I am going to take the base, write it down here, take the number, and that will equal the exponent. If I type this expression in my calculator using my log base button, that is approximately 61.959 equals 4t. So when I divide by 4 to the nearest tenth of a year, I get 15.5 years. The next one says a population of 950 bacteria grows continuously at a rate of 4.75% per day. Right, an exponential function n of t that represents the bacterial population after t days and explains the reason for your choice of base. Determine the bacterial population after 36 hours to the nearest bacteria. So in this question, we have to be really careful because the first thing it asked me to do is write an exponential function n of t. Now I'm going to use the formula p e to the rt because this is growing continuously. Now I don't want to even look at this 36 because we're just trying to write a function first. So this is going to be, the start value is 950, the base is e to the 0.0475 t. So you have to have it with the t plugged in. Now my reason for that choice of base, I chose the base is e, right? E because it is growing continuously. Okay, so we know that's the appropriate base. Now to evaluate the problem, I'm going to erase this part here. Now we want to know how much there will be after 36 hours. Now our time is measured in days. So when we plug in 36 hours, 36 divided by 24, that would be 1 day, is 1.5. So we're plugging in 1.5 days. So n of 1.5 equals 950 e to the 0.0475 times 1.5. Okay, so when I type that in, that is going to give me to the nearest bacterium 1020. The next one says a radioactive substance has an initial mass of 100 grams and its mass halves every 4 years. Which expression shows the number of grams remaining after t years? So we're starting with 100. This is halving every 4 years, so I'm using my half-life formula, which is p times 1/2 to the t over h. My half-life, or how long it takes to halve, is 4 years. So this expression is correct.